temperature. That means either we can convert the both one into Celsius, or we can convert them into Fahrenheit, and this is easier to convert in Celsius scale, and this is very common also. Here if we want to convert the Fahrenheit into Celsius scale, we just um, um, assuming that final temperature here will be T2, and the relation here will be T minus T F, or in the temperature in Fahrenheit scale, TF minus 32 divided by 9 equals T2 divided by 5, and from here we just get the here TF is for temperature in Fahrenheit scale, and is given 120 degree Fahrenheit. So using this relation we just get the final temperature T2 will be 48.88 degrees Celsius. So we have got the final temperature. Now we can calculate the change in temperature by making the difference between T2 and T1. But we have to measure another value here, that is the value of mass m. And how we can calculate it? In our question, the area of upper plate of the upper surface of the plate is given, that is 1.6 into 10 to the power 4 centimeters square, that means 1.6 meters square, and the height of the plate is also given 10 centimeter, and converting it to meter it will be 0.8 meter. So as we have got the value of area and height, we can calculate the mass from the equation. As we know, the relation between mass and density is rho equals m by v, and from here v is equals area is multiplied by the height, that means area into height. So putting this relation on our desired equation, in this equation we will just have the values of specific heat capacity, because the density of that material, that means the plate material, is given 7800 kg per meter cube, and at the same time the absorbed heat that is also given 3.38 into 10 to the power 4 kilojoule. The heat is given here, the density is given here, the area and height are also given, and using all this information, here we just get the specific heat capacity will be 799.39 joule per kg per Kelvin. You should practice some different kind of math, and you must have to concentrate that about the unit, because sometimes you just perfectly do the whole math, but finally you just make mistake in writing the proper unit. So be careful, and if you just follow the equation, and then you will get how to calculate a unit from that. So be careful about the unit here, or in all questions, all mathematical type question, because making any fault in writing unit, the marks will be deducted over here. So we have got the answer of question 3, the specific heat capacity for that plate material, that will be 799.39 joule per kg per Kelvin. So the question number D is we have to now calculate the question number D. Our question number D is, if you have written the question already, then you just have a look on the question. Question number D was, if the width of the plate is 8 centimeter, then will it be safe for you to travel on that day? In our staying, the area was given, the height was given, but in question number D, the width is also mentioned over here, and if the after the expansion of its area, while the train is moving over it, then will it be safe for you or not? So here calculating the linear expansion, we have to calculate the linear expansion of that plate, because the as the train will be expanded over here, and we have to calculate the linear expansion. For that, our desired equation is L2 minus L1, that means del L equals to alpha L1 into T2 minus T1, where we know that alpha is the coefficient of linear expansion. So as we are determining the linear expansion, we have to use the coefficient of linear expansion here. Though in our question the coefficient of volume expansion is mentioned, we will just calculate the coefficient of linear expansion. First of all, let's just note down all the values given on the stem. Again, here the area of surface is 1.6 into 10 to the power 4 centimeter square, and width is given 8 centimeter, and area is equals length. As we know, area is equals length into width, so we can calculate the length of the plate. That will be area divided by width, and that will be finally calculating, we'll get it 20 meter, 2000 centimeter, or 20 meter. And in our question, the coefficient of volume expansion is given, gamma is given 33 into 10 inverse 6 per Kelvin. So there is a relation between volume expansion, area, coefficient of volume expansion, coefficient of area expansion, coefficient of linear expansion. We are using the relation between coefficient of volume expansion and coefficient of linear expansion, and that is coefficient of linear expansion is equal alpha is equals gamma divided by 3. That means by dividing the volume expansion, we will get the coefficient of dividing the volume expansion by 3, we will get the linear coefficient of linear expansion, and that will be 11 into 10 inverse 6 per Kelvin. So we have got the linear coefficient of linear expansion. We know the change in temperature. At the same time, we have determined the initial length of the plate. So now we have to determine the increase in length, and if we assume it as L2 minus L1, so we can use the equation L2 minus L1 equals alpha L1 into T2 minus T1, where L2 minus L1 is the change in length, that means length increase, alpha is coefficient of volume linear expansion, L1 is initial length, and T2 minus T1 is the change in temperature. Sorry boys. So finally, putting all the values over here in we will get the change in length, and there will be 7.45 into 10 inverse 3 meter, but in our staying, the width of the plate is given in centimeter unit. We can convert the answer into centimeter unit, or we can just do another thing, we can convert the width that is given in centimeter, we can convert it into meter also. Here we are converting the projected answer into centimeter unit, and that will be 0.745 centimeter or 7.46 millimeter. We just need the value in centimeter, that is 0.745 centimeter. So we are just comparing the result here with the given width, that is 8 centimeter. So in our stain, another point is included, that the 2 centimeter space was kept empty between the two plates, because due to expansion the plate will increase, so 2 centimeter space is kept over here, over there. So as the projected value of linear expansion is 0.745 centimeter, and the space is kept between the plate is 2 centimeter, that is larger than the linear expansion of 0.74 centimeter, that means that our given space is more than the increase in length. So we can just here say that it will be safe to travel on train on that day on that line, because the projected space or given space here is 2 centimeter, and the increase in length will be 0.745 centimeter. So though there will be an expansion, it will not cross the safe limit. So anyone can travel on that route with very easily and without any fear. So this is the question, and the same was a very elaborated one. You must practice this type of questions, and uh, every just carefully follow every point while practicing. And that's all for now. We will discuss some other topic on some other classes. Take care and goodbye for now.